So today we're going to cover Chapter 7, Section 3, and we're going to be solving trigonometric functions. What we're going to be bringing back is a lot of skills, our Algebra 1 skills for solving equations. We're going to be bringing back the unit circle. Notice I put in this little picture here at the bottom. It's not in your notes, but this was from the Chapter 5 notes. And this was the solution intervals. So remember, whenever you're solving the sine and the cosine, remember it needs to be a fraction. Whenever it's secant or cosecant, it's got to be a number that is going to be greater than 1 or less than -1. And then tangent could be any number. So reviewing these solution intervals, which was from Chapter 5 notes, you can go ahead and when you go to do the questions, you're going to know, oh, wait a minute, this isn't on the unit circle, or this one can't be solved, because if I ask you, for example, to do sine x and find the value of x when it equals 2, you should recognize that this will never happen. This is no solution. So we're bringing back those solution intervals. We're also going to be again, using the unit circle. And then some of the questions will be calculator questions. And some of the questions will need to be factored. If it can't be factored, you're going to need to use quadratic formula. So we're bringing back a lot of skills in this lesson. Now, when it says to give all the possible angles, what you may see on a standardized test is whenever you see plus 2n pi or plus n pi to a tangent, this just means that there's an infinite number of solutions. But what we're going to be doing is restricting where we're looking for our answers, and we're going to restrict them to the unit circle. So from 0 to 2 pi, and notice the parenthesis around 2 pi, and 2 pi will not be an answer. So we're going to restrict it to the unit circle, but just recognize that if it wants infinitely many, you would put, once you get your 2 answers or 4 answers, you would either add plus 2n pi to sine and cosine or plus n pi if it's tangent. We're also going to be bringing back our all students take calculus. So let's go ahead and take a look at our first example. So what we're going to do here is, notice I added a picture of a unit circle because I'm going to be using this. So what I need to do is I need to try to isolate the trig function. So I'm going to go ahead and get my signs together. So I'm going to add sine x to both sides. And then now I have 2 sine x plus the square root of 2 equals 0. I need to isolate that sine x. So I'm going to move the square root of 2 over. And now I have 2 sine x equals negative square root 2. Again, I'm working on isolating. If at first you want to think of this as just being, take away the word sine and do x plus root 2 equals negative x, and then solve for x, get 2x plus root 2 equals 0, and then move the root 2 over, and then you get 2x equals negative square root 2, divide by 2, and x equals negative square root 2 over 2. So this is how you could do it if adding in the trig word confuses you. But let me go ahead and finish it now with the word sine x. Divide by 2. So sine x is equal to negative square root 2 over 2. So here again is where I use my unit circle. So you're going to go back and remember that sine, remember, of x, we're looking at the y. Remember it was y over r, but when it's the unit circle, our r value is 1. So we're looking for a y value that equals negative square root 2 over 2. Here's where you can do your all students take calculus to narrow down which quadrants sign is going to be negative. So if I do my all students take calculus, sign is going to be negative in quadrants 3 and 4. So I'm going to go up to my unit circle and I'm looking for an order pair where it's y is equal to negative square root 2 over 2. So if I come up here to my unit circle and I can see that at 5 pi over 4 and at 7 pi over 4. So that is going to be my two answers for sine. So let me go back here now. And my two answers for x, my angle measure, x is going to equal 5 pi over 4 and 7 pi over 4. Now, this is what you're going to be doing on the test because I'm going to restrict you to only numbers on the unit circle. So from 0 with a bracket to 2 pi. Now, on an SAT, if they say give the general form or give all values, then what you would do to this would be to take 5 pi over 4 and you would add 2n pi. Or 7 pi over 4 and add 2n pi. So you can keep getting more and more angles by adding 2 pi each time. It's got an infinite number of solutions. This is considered the general form. So you may see this on an SAT or an ACT. Let's try number 2. So R in the unit circle equals 1. So this is really y over 1. So this is why I'm just looking at the y when I'm doing sine. So remember, why should you sin? You look at the y. Cosine, we're going to look at x. So for number 2, again, we want to isolate the trig function. So I'm going to go ahead and add sine x to both sides. And I get 2 sine x minus root 2 equals 0. I need to get the 2 sine x by itself. 2 sine x equals the square root of 2. Divide by 2. And now I have sine of x is equal to positive square root 2 over 2. So again, we can do our all students take calculus. Sine is going to be positive in quadrant 1 and in quadrant 2. Remember, sine looks at y, so I'm looking for an order pair where y is equal to 2 square root 2. And in quadrant 1, if you come up here to the unit circle, positive 2 root 2 is pi over 4, and in quadrant 2, it's 3 pi over 4. So now let me go ahead and put those answers down here. So my x values or my angle measures are going to be pi over 4 and 3 pi over 4. And again, if they said to give the general form, you would be doing pi over 4 plus 2n pi and 3 pi over 4 plus 2n pi. And again, I'm not going to ask you to do this part of it. This is just for standardized tests. Let's do number 3. Let's do tangent. Now, if you recall on the previous slide for tangent, we're only going to be looking in quadrants 1 and 2 because for tangent, it's only going to be from 0 to pi. Because remember, we just graphed tangent, and remember the normal period length for tangent is only pi, it's not 2 pi. So we're only going to be looking in quadrants 1 and 2 when we're solving a tangent equation. So again, my goal is to isolate the trig function. So 3 tangent squared x, now it's the variable is changed on me, divide by 3, tangent squared is equal to 1/3. I don't want tangent squared, I need to square root it. So when I square root this, I now get tangent of x is equal to plus and minus the square root of 1, and I could do them individually. Square root of 1 is 1, but then the root's still in the bottom, so I got to rationalize. So then tangent of x is equal to plus or minus square root 3/3. Now, this is where when we did the chapter 6 test, remember for tangent, there's only 3 scenarios. So because we only have 3 ordered pairs on this whole unit circle, remember we either have a 1/2 root 3/2, or we have root 2/2, root 2/2, and then the signs are just different depending on the quadrant. These are the 3 ordered pairs that you see repeated throughout the unit circle. Remember, tangent is equal to y/x. So if you want to go ahead and divide your y/x on all of these and memorize all of these tangent values and then quickly put them on your unit circle, you can do this. So y, root 3/2, divided by 1/2, keep, change, flip, and make it 2/1. And when you multiply this, it's just square root 3, because the 2 simplify. Then the next one, root 2 divided by root 2/2, keep, change, flip it, and then this just simplifies to a 1. And then here, 1/2 divided by root 3/2, keep, change, flip it. This gives you 1/root 3, rationalize it, root 3/3. So this is the one that I needed, if you notice, and let me go ahead and put these on my unit circle. So for the first order pair, the 1/2 and root 3/2, this one is the root 3, this is the 1, this one gives me the root 3/3. Now remember, we're only looking in quadrants 1 and 2, so if you want to go ahead and put this as negative root 3, negative 1, and negative root 3/3. So if you want to divide these ahead of time, you're already going to know the reference angle for when you get that tangent value. So we can see we were looking for this one, and we were looking for plus minus. So we're actually going to put both answers. So it's going to be pi/6 and 5pi/6. So let me come back here. So my x values, again, tangent is only looking in quadrant 1 and 2 because the restriction is going to be from 0 to pi. So this answer is going to be pi/6 and 5pi/6. And again, if they wanted the general form, for tangent, it's not 2 pi, it's just n pi. And then 5pi/6 plus n pi. That would be the general form on a standardized test. Let's try number 4. Again, let's isolate the trig function. Gonna add 3 to both sides. So 4 sine squared x equals 3. Divide by 4. Sine squared x equals 3/4. I don't want sine squared, so I got to square root it. And then I get sine x is equal to plus and minus the square root of 3/2. Remember, sine, we look at y. Now let's go ahead also, not plus and plus minus. So here we don't really need to narrow down our quadrants because plus minus, it's going to be all 4. So I'm looking for a y value that is equal to positive and negative square root 3 over 2. And when you come up to your unit circle, my y value, let me fix this. My y value where it's square root 3 over 2 is going to be the pi over 3. And then the 2 pi over 3, 4 pi over 3, and 5 pi over 3. So it's all the denominators of a 3. Go back down there and write them all in. So my answers here for x are going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And again, if they wanted the general form, to each one of these, you would add a 2n pi. But again, for your test next week, I just want the values or the angle measures from the unit circle. All right, so for number 5, what I need to do is get all my trig functions on one side. So I'm going to add, set it equal to 0. So I get cotangent times cosine squared x minus 2 cotangent of x equals 0. I'm going to factor out a GCF of cotangent. So cosine squared x minus 2 equals 0. I now set each of my factors equal to 0. So cotangent x equals 0. And then this one as well. Cosine squared x minus 2 equals 0. I'm going to go ahead and finish solving this one. Add 2. Cosine squared x equals 2. Square root both sides. And cosine x is equal to plus and minus the square root of 2. Now, the square root of 2 is approximately equal to about 1.4. This is out of my range. So this one gives me no solution. Because remember, cosine has to be a number in between 1 and -1. Cotangent, I can solve. Whenever I see a 0 here, I'm not going to be using my values in the quadrants. I'm going to be using my axis angles. So cotangent, remember, is going to be x over y. So what I need to do in order to get it equals 0, this x, the 0 has to be in the numerator. So I'm looking at my unit circle and I'm looking to see where x equals 0. So if I come over here, you can see that x is equal to 0 right here and right here. But tangent and cotangent are only looking from 0 to pi. So I'm not going to use that one. I'm only going to list my answer as pi over 2. So my only answer here, because tangent and cotangent only go from 0 to pi, so the only answer here is pi over 2. So for this one, I need to get all my trig functions on one side, set my equation equal to 0. So sine squared x minus 2 sine x equals 0. Again, I'm going to factor out a GCF of sine x. So sine x minus 2 equals 0. Set each of your factors equal to 0. So I have sine x equals 0. And then this one, sine x minus 2 equals 0. This one I have to solve. So sine x equals 2. Again, this one I'm not square rooting, but this is out of my range. So this one's no solution. And again, for this one, what I can do is look at my axis. And again, I'm looking for for a y equal to 0. And then if you look at your unit circle, I'm using these points here. So this is 1, 0. And over here would be negative 1, 0. So I'm going to get 0 and pi as my answers. Number 7. This is a trinomial. So if you want to think of it as 2x squared minus x minus 1 and factor it first this way and then add the sign back in, you can. Factors of negative 2 that give you negative 1. And again, you can either factor by grouping or guess and test. This will factor into 2 sine x plus 1, sine x minus 1. And again, you can FOIL it and make sure it goes back, and it does. So now I set each factor equal to 0. So 2 sine x plus 1 equals 0. And then this one, sine x minus 1 equals 0. Subtract 1. 2 sine x equal negative 1. Divide by 2. Sine x equals negative 1/2. And then this one I'm going to add 1. Sine x equals positive 1. So for this one, I'm looking for the y where it equals negative 1/2. And I know that the y, so for the red one, I'm looking for y equal negative 1/2. I can do my all students take calculus, and I know that sign is negative here and here. And if I come up to my unit circle, I can see that negative 1/2 is going to be happening here at 7 pi over 6 and 11 pi over 6. So that's the answer for the red one. So my first answer here is x is equal to 7 pi over 6 and 11 pi over 6. For the black one here, I'm going to use my quadrant angles, and I'm looking for a y equal to 1, and that's going to be at pi over 2, because it's going to be this order pair up here, where it's 0, 1, so it's pi over 2. So your 3 answers are pi over 2, 7 pi over 6, and 11 pi over 6. The last one, again, is also a trinomial that can be factored. And again, if you'd prefer to do it as 2x squared minus 3x plus 1 first, get your factors of 2 that give you negative 3, you can do that. Let me just bring it on down here. So this will factor into 2 sine x minus 1, sine x minus 1 equals 0. Set each factor equal to 0. And then this one, solve it by adding 1. This time I'm looking for positive 1/2. So sine x equals positive 1/2. So all students take calculus. I'm looking in the top 2 quadrants. And again, same denominator. It's a denominator of 6. So x is going to be where y equals 1/2, pi over 6, and 5 pi over 6. You'll look up at your unit circle. The blue one, I'm looking to see where my y value will equal 1. So I'm looking for a y equal to 1, and that comes from the quadrant angles again. Same answer I got up above. It's just going to be pi over 2. So your 3 angles, pi over 6, 5 pi over 6, and pi over 2.